They have questions about the homework problems. So I'm going to select some problems to discuss. And our main focus will be algebra and the number series. Okay. So we're going to focus on several problems. The first one is the problems on the numbers. Okay. So the first problem is as follows. So here's a question. So if the product of three different, be careful, read the problem careful, three different positive integers is equal to 7 cubed, what is the sum of these numbers? Okay. So when you see the problem, you just read the question carefully and why they say three different positive integers. So the product of three positive integers equal to 7 cubed. Okay. So the three factors. Okay. So you have to find the three factors for 7 cubed. They're all different, right? And at the very beginning, you said, okay, 7 times 7. If you forgot, you know, the condition requirements, three different positive integers, then you just think, oh, okay, 7 times 7, 7. So 3 sevens, the sum is going to be 21, which is wrong. Okay. So 7 cubed can be written as the product of three different integers. Right? 1, 7, 49. Okay. This is the only way you can make them different. Okay. So three different factors. So therefore, the sum is going to be 1 plus 7 squared. So if you read the question carefully, you will solve the problem, okay? Otherwise, you know, about 10 to 20% of students end up with 21 because it's product of 7. 7 times 7 times 7, right? Of course, the sum of the three integers is going to be 7 plus 7 plus 7 will be 21, okay? So just needed to be careful when you read the problems. Okay. Okay, another one is what is the sum of the final three digits of the integer representation integer form, okay? 5 to the 100. 5 to the 100 itself, it's integer, but the integer representation means, you know, you have to write down all the digits. But of course, impossible. This is a huge number. But what we need is just the last three digits. But how can you figure out the last three digits? We have no clue. Now, I can figure out the last digit quickly because we always do that. What is the last digit? What is the last digit, right? So, but if you know how to find the last digit, use the same idea, you probably can get the last three digits because you're going to look at the pattern, okay? So 5, yeah, all you have to do is just write down the first digits, right? 5 to the 1 is going to be 5, okay? 5 squared is going to be 25. Okay, I got two digits now. 5 cubed is going to 125. So 1, 2, 3, 1, 2, 5. Right? Then I don't see any pattern here, but at least I can see 2, 5, 2, 5 shows up repeatedly. Okay? 5 to the 4th, and you multiply that, it's 200, 625. See? 25 stabilized. This is the, yeah, I think it's always there, okay? So only change it probably the third digit, okay? Right now, 1 becomes 6, okay? 1 becomes 6. And the 5 to the 5th, use a calculator, is going to be 3,125. Okay, so 1 to 6, 60 back to 1. Okay, 25 is still there. 25 is still there. And then do one more. Okay, you find out 3,125 multiplied by 6, and this is going to be what I got is 15,625. So it looks like the 3 digits shows up repeatedly, right? 125, 625, 125, 625, and keep it going. And if you don't believe that, then you multiply by 5 again. I got 78,125. So 125. So it shows up alternatively. All right. Now it's clear, right? Now it's clear, and 5 to the 100 will be something, 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 and this should be 600. 625. Okay, we don't need to know the other digits. Right? So this is a pattern. Okay, you at the end of the evens term, it will be 625. Then others term will be 125, 625, 125. Right? It's, you see, 625 corresponds to the even number, and the 125 corresponds to the other number. Okay, so that is the reason. So therefore, the 3 digits will be always the 100, 5 to the 100. The last 3 digits will be 625. If you want to find the sum, just 6 plus 2 plus 5, then you get the answer, 13. Okay. Okay. So questions why there's such pattern there, then if you can prove it, then you can try, okay? Try to prove this is always true, but I just make a, on the exam, you just quickly looks for the pattern, okay? So last digit is always equal 5, so the pattern is clear, okay? And now, after you look at all those terms, you're given the calculator, okay, when do the, and you quickly, do the calculation. You see, if 5 to the 100, probably don't get any numbers because the calculator, it's beyond the capacity of the calculator screen. The screen, it's not long enough to show all the digits. Okay. So the pattern shows that the last 3 digits will be 6 to 5, then you add them together. Okay. So there are some other problems. You have to find the last digit. For example, what is the last digit of not a 5? What is the last digit? The similar question is just find the last digit, not 5. Okay, what is the unit digit of 7 to the 100, for example. Okay, right? Yes. And to do that, we just look at the pattern. Okay, so it's 7 to the 1 is a 7, right? 7 squared is 7, 49. Okay, then 7 cubed is 7 times 9 is going to be, you don't need to know the other digits, just 7 times 9. You get 3, okay? Then 7 to the 4th, 3 times 7 is going to be 1, 21, So you just 1, the last digit is 1. So you can see that then from 5, you repeatedly get 7. So this will be periodically shows up 7, okay? So 100s, okay? So 100s, how many blocks there, right? 100 divided by 4 is going to be 25, okay? There will be 25 blocks there. So the last one will be 1, okay? Right. So there will be 25 blocks, each of them yeah, each of them have 4 integers. Okay, each of them contains 4. So the answer will be, yeah. So the last one, this is 25th block, right? So it's a 7, 9, 3, 1. So the last one will be 100. This is the 100th integer. The 100 integer end up with 1. So that's why the digit, yeah. Yeah, 7 to 6 is going to be the last digit will be 9. Okay. All right, so we will get, yeah, the last digit will be the last digit of 7 to the 100 is going to be 1. Okay. It's a very similar idea to, you know, yeah, the one we just did. Okay. All right, so now we are going to look at the next problem. Suppose that 50 factorial is written in the form n times 10 to the power x, where n is an integer. Okay, so what is the largest possible value of x? So that means how many zeros at the end when you write down, when you express 50 factorial in the integer representation form. Okay, so we just need to know, yeah, if you multiply this out, so you get 0, 0, 0, 0, 0, to the x, you have an x zeros here. Okay, right? So you need to understand how do we get 0, why we get 0. Yeah, yeah, 10 times only when 2 times 5 is given 0, right? And when you look at 50 factorial, we search for the factor 5. So you show that you only write down this 5, 10 contains 5, 15, 20, 25, 30, 35, 40, 45, 50. But be careful, this 2 special number contains 2 5 there. Okay, 2 times 5. Okay, so how many factors are you going to get? You are going to get total, you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so you're going to, at least you're going to get some number times 5 to the 12. That's the first thing. But we know that 2 times 5 gives you 10. How many factors to that? There are more factors to that than anything because there's so many even numbers there, right? 50, right? There are 25 even numbers there. At least there's 25 factors to that. So that's the reason you can express as 10 to the 12, okay? Okay, so the largest possible value for x is going to be 12, okay? X is going to be 12. Okay. So those are the number series problems. Let me find another one. All right, I have a nice problem here. So the next problem I want to discuss is the product of three consecutive odd integers is 315. What is the list of these three integers? Now for this problem, you cannot solve the problem directly. You cannot try to find the three other consecutive odd numbers, multiply them together. Then you don't know because you don't have experience to find out. So you have to do the backward. Okay, suppose you have a P, Q, R, the product of three numbers is going to be 350, right? 315. So P, Q, R are consecutive integers. But how do you find the P, Q, R? You just do backward. You factor 315. Okay, you factor 315, then 315. First of all, it is divisible by 5, but you can also see that it's divisible by 6. Okay, so you can use a calculator quickly factor this. Okay, so 315 divided by 5. 315 divided by 5, it's going to be 63. So 5 times 63. Then 63 is going to be, right, 7 times 9. Okay, so then it clearly gets the product of 3, right? You can get the product of the 3 consecutive odd integers right away. Okay, so then the answer, what is the list of the integers? Of course, this is a 5. You get all of them, right? The next problem in a similar situation is going to be, we know that the product of 3 consecutive positive integers is divisible by 6 factorial. What is the least possible average of the 3 numbers? Now, when you try to find the average of 3 numbers, come on, this is their consecutive integers. So you can write down in this form. So consecutive integers 3. So actually the average is the number in the middle. The average of them is nothing but the n. Okay, so n is the average value. So all you need to do is just find the middle number. Now divisible by 6. Okay, divisible by 6. So you have to find the product of 3. So you look at 6 factorial first. Okay, 6 factorial, right? It's going to be 1 times 2 times 3 times 4 times 5 times 6, right? Okay. So let's regroup them, okay? I notice that if you regroup them, 6 is 2 times 3, right? 6 is 2 times 3. Well, we're trying to see. 6 is, yes, that's 2 times 3. Okay. I find out this can be written as 8 times 9 times 10. Right? Okay. So 9 is 3 times 3, right? But 2 times 4 is 8. 2 times 5 is going to be 10. So I come up with the product of 3 consecutive integers, 6 factorial. If you notice this, then the problem is simple, right? What is the least possible average of the 3 numbers? The least, so the product of 3 consecutive positive integers, the smallest of those numbers will be 8 times 9. So the product itself should be just 6 factorial, okay? So the answer will be just 9, okay? Because this is already the product of the smallest product of 3 consecutive integers. So once you look at all the factors of 6 factorial, okay, then you will see that. Okay. One more number series problem. So what is the sum of the 11th and the 44th digits to the right of the decimal point in the decimal representation of the number, okay? All right, so first of all, what kind of number you're going to get? If you just look at the 1 over n. If you look at the 1 over n, okay, this is a rational number. Rational number, by definition, is going to be the fraction. This is special fraction. So that rational number, if you express it in the decimal representation, either it has terminate digits, or it has a repeating digits. Like when half is 0.5, it's terminate with terminate digits, just only 1 digit, right? Up to the decimal point. But 1/3, you have 3, 3, 3, 3, it's repeating. Okay, so that's only 2 possible cases. Now it could be repeating 2 digits repeating. Like in this case, just only 1 digit, 3, 3, 3, 3. Okay, and then you can look at the 7. Now you're supposed to use a calculator, right? So when you look at the 7, you use a calculator, you get 1, 4, 2, 8, 5, 7. Wow, it's not repeating. Then you see 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. So those 6 digits are repeating. Okay. So yeah. So now it's clear that you can find the 11th digit and the 44th digit, right? So once you see the pattern, then you can get the 11th digit and the 44th digit. There's the 11th digit, and the 11th digit will be here. How many digits, right? 6, right? So that one's 12. Otherwise, the 12th one is 7. So the 11th is going to be, the 11th digit is going to be 5, okay? You can also figure out the 44th digit. The 44th digit, it depends how many you divide by 6, right? Because one block contains 6 digits, okay? So 42, the remainder is 2. So that means there are 7 blocks here plus 2 more digits. So that should be equal to 4, okay? Yeah, 7 blocks and plus 2 more digits. 2 and then 1 and 4. So the 44th digit is 4. Then add them together, okay? So you get 9 if you want to find the sum. Okay, so I said that today my focus is about number theory problems. Now I'm going to talk about algebra. Okay, algebra, the story problems. I find out at least that Joshua gave me his homework, and the problems he made mistakes is most of them are the story problems. Yeah. So let's look at those problems. All right, so let me write down this problem. This is the problem number 33. The question: how do we? Yeah, it's very similar to number 17, number 33. Those are the story problems. A very similar idea, and they're not difficult, but depends how do you analyze it. Okay, so let me borrowing print fills 0.5 little bottles from a 56 little tank. Okay, a flat consists of 24 bottoms. Okay, the question is how many complete flats can be filled from a single tank. Okay, so let's understand. Let's understand the problem. You see, how many so a tank, 56 liter tank, how many bottoms you're going to get, right? So you're going to get because the number of the 0.5 little bottoms. So a tank, a 56 liter tank, you can equivalent to, because divide by 1/2, it's going to be 56 times 2, right? Bottoms. Okay. So this is a number. Then you know that a flat consists of 24 bottoms. All you have to do is divide by 24. Okay. So you right. So the question is how many complete flats can be filled. Okay. You just bought 24 bottoms. Using 24 bottoms, you can fill a flat, right? So all you have to do, if you understand this, then 56 times 2 divided by 24. Unfortunately, this is going to be 4.666. So that means you can only fill 4 flats. Okay, that means you can only fill 4 flats. If you get the integer, then in order to, there's some left over, because what is left, it can only fill a portion of the flat. Okay, so just depends how many 24s there, right? You have a remainder. That's right. 52 times 2 divided by 24, you get a 4 plus. In other words, you get 4 plus some number here, the remainder, and then divide by 24. So that means what is left is not enough. It's less than 24. So you only get, you can only fill complete 4 flats. Okay, so this is another tricky problem. If you understand it carefully, then if you understand the problem and step by step, you can solve it. The next problem is a little bit tricky. Okay, where's the problem? Okay. I'm trying to find it. Okay, so that's the 54 is a little bit tricky problem. Okay, so it says that a peach contains 4 1/3 cups of water. Okay, that's the first condition. A 1/3 cup scoop is used to transfer water from the pitcher to a bowl. Okay, so just have one container for into from here to here. Okay, so total you have this many waters, and but you use a 1/3 cup of scoop. Okay, to transfer the water. Yeah, right. That's the way you do. The question is, how many scoopers are needed? Okay, until the bowl has more water than the pitcher. Okay, the common mistakes is you just find out how many scoopers are needed to empty the pitcher. Okay, that's a common mistake. You don't need to empty it. You just make sure the water in the bowl is more than the water in the pitcher. Okay, so okay, so that's right. How do you solve this problem? Well, I think you can. So how many? So starting problem we have, let's call it x. Okay, x. So you write down the equation. Okay. So write down the equation. X on this side, you will get 1/3 times x, right? The left-hand side, right-hand side. Oops. Okay, and this is in the bowl. Okay, this is so much what you can get. The left-hand side. Okay, the left-hand side. This is how much you lose, transalt, right? So it's going to be, it's subtract 1/3 x. Okay, we have to make sure this is less than that because I need more water in the bowl. So you actually solve this in code. And x is integer, okay? X is integer, remember. Okay, so what you get is, right, let's express this as a fraction. And I think it's 13/3 minus this. Okay, then you my writing is wrong. Okay, it's 1/2. Okay, so the exact same problem. It's 1/2. I just was checking. Okay, so Okay, this is 1/2. That's going to be 9/2. Okay, so let's solve this problem. Solve this inequality. 9/2 less than 1/3 plus 1/3 is 2/3, and then you solve this inequality by multiply by 3/2. Okay, so what you get is x should be greater than 27 divided by 4. Okay, and it's going to be 3 point something something something. So n is the integer and must be greater than no, sorry, not 7. 6 point something. Okay, and you don't need to know the details. Okay, 4 times 7 is 28, so just 6 point something. So x is the integer, so x, the smallest value for x should be 7. Okay, right? X, we know x is integer. Okay, we want to make sure the what in the boys is more than the what in the picture. Okay, so you have to solve this inequality. This is what you have to start. Okay. Sometimes you solve inequality, sometimes you solve equation, but this time you have to solve the inequality. And then you get this inequality, x is greater than 27 divided by 4, which is about 6 point some number, right? And since x is the integer, then you have to, yeah, x should be equal to 7. Okay. All right, let's look at another story problem. All right, so the next problem is a story problem, and this is I just want to tell you the trick here. The cost of 5 pencils and 1 pen is $2.50, and the cost of 1 pencil and 2 pens is going to be $1.85. My question is, what is the cost of 2 pencils and 1 pen? Right? So the cost of the price for the pencil would be called X. Okay, X is the price of a pencil. Okay, Y is going to be the price of a pen. So you have to write like this first, and then you write down the equation. Maybe you have to solve the equation, maybe you don't need it. Okay, so the cost of 5 pencils will be 5x, and the 1 pen is going to be $2.50, $2.5. Then the cost of 1 pencil and the 2 pen equals $1.85. Okay, what do you have to find out? You have to find out the cost of 2 pencil and 1 pen. All right. So when you look at this equation, so you want to find the 2x plus 1. But you're given those 2 equations. You write down the equations. Okay, so you were trying to solve for x and y, right? Then add them together. How many computations you have to do? You have to find a way eliminate the x variable, y variable, blah blah. And finally, without making mistakes, you will find the x and the y. Then x times 2, then plus y, finally get answer. So the easiest way to solve this problem is just equation 1 plus equation 2. Okay, then you will see that the left hand side gets 6x plus 3y equals 2.5 and plus 1.85. Now you can add them together. I think it's 4.35. Okay, yes. So yeah, so 6x 3y, if you take the factor of 2 out, is 2x plus y is actually 4.35 divided by 3, okay, which is 1.25. Okay, this will be the answer. You don't need to find x, you don't need to find the y, but you can find 2x plus y quickly. Okay, so when you do the problem, just look at the line and look at those two equations and look at what you have to find out. Maybe you don't need to find the value x and the value for y, okay, because you just need to find 2x plus y, okay. All right, now I'm going to talk about a little bit about algebra. Those are the equations. Right, my next one is the two algebraic problems. The first one is if f(x) is going to have a absolute value x plus 3, g of x is going to be x squared minus 6. Okay, what is the value of f g of 2? Okay, now you have to understand what does that mean, g of x. So this means g of x represents x minus 6. So when say g of 2, and that is going to be just plug 2 for x into the formula. So you get 4 minus 6, which is 2, negative 2. Okay. Then, so g of 2 is a number. Okay. So f of g of 2 is f of negative 2. So the question is, what is the value of f of negative 2? Well, just plug negative 2 for x. Yeah. Then you can put negative 2 for x into the above formula. So you get negative 2 plus 3, and then that is going to be 1. Okay. So the answer is 1. Okay. Okay. So Alan says 1 for 1. Okay, so it's negative. Yeah, negative. Another, yeah, I will put this if it's recorded. I will put some on YouTube. Okay, if you want to listen again, you have to send me a request, okay, by email. Okay. All right, so the next problem we want to understand is, so for what value of x is the expression, this is the expression, strange expression. Okay, it's not defined. Now, what does it mean it's not defined? Okay, you have, what is not defined? Only when the denominator is 0. If you have a number a divided by 0, this is undefined in mathematics. Okay, this is undefined. Whenever that shows up as 0, it's undefined. Otherwise, it's always defined. It's a fraction. Fraction is always defined except for when the denominator is 0. So all you have to do is just to solve this equation, okay, to see when it's going to be 0. When you look at this equation, right, there are many ways to solve this quadratic equation. some student can factor this equation, right? Factor this quadratic function. Some students have to use the quadratic formula to find it. So it's really up to you. Okay, I'm going to just factor this. It's going to be 10 squared. Okay, x minus 10 squared. Okay, so x is going to be 10. But you can also use the quadratic formula by the quadratic formula, right? You can say negative b plus minus b squared minus 4ac divided by 2. Then you will see that negative 20 squared minus 400 is going to be 0. So it's going to be 20 over 2, that's just 10. So you can use a quadratic formula to get 10. But sometimes you have experience, you can quickly factor the quadratic function, okay? Then you solve the problem. So when x equals 10, the denominator is going to be 0, therefore it's then defined. So the answer is 10, okay? This is the answer, okay? Yeah. So that is, we switch to the topic, how to factor polynomial, right? So you suppose, yeah, let's try to factor x squared minus 3x minus 10, okay? How to factor this, right? You know, sometimes you have to find the x for which is going to be 0, right? So if you can factor this, you suppose you can factor it, okay? Let's do it. All right, so it's going to be, I can write n and x minus m, for example, right? Okay, so when you multiply this out, it'll be x squared minus nx and minus mx plus nm. So you will get, maybe let's choose positive sign, doesn't matter, okay? So it's n plus m, x, and m. So what you have to do is the product of those two numbers is going to be negative 10. Okay? And this is going to be negative 3. So you have to figure out what is negative 10. Negative 10 is negative 2 times 5. Okay? You can put a negative sign in front of 5, you can put a negative sign in front of 2. But if you put a negative sign in front, this can be 2 times negative 5. But then the sum should be negative 3. So clearly the choice is for one of the numbers 2, the other number is negative 5. Okay, so that's why it's x is plus 2, x minus 5. Okay, so this is the way, how do we factor the polynomials, quadratic functions. Well, the last 10 minutes, I'm talking about percentage problem. Joshua had troubles with percentage problems, but I'm not sure you always do the problem correctly. So when we have a two quantity, A, change it to A product, okay? So there's a change, right? So what I'm gonna do is I'm gonna look at the difference, okay? And divide by, compared to the original one. Then I have to multiply by 100% and get, let's call it a percent, okay? So it depends if A prime is larger than, if A prime, yeah, then depends on the value, could be plus minus, let's write it this way. So R could be positive, could be negative. Yeah, the difference, right, the numerator, okay? When you get a negative number, that means it decreased by 1%. Otherwise, we can say it's an increase by 1%. Okay, so if it is positive, yeah, so that's two cases. is positive R%, then we say that it's increased by R%. Okay, if you get negative R%, then we can say that decreased by R%. Okay. All right. So now look at this identity. Okay, look at this identity. You can divide both sides by 100, so it's R over 100. This is the right. Then you multiply by A. Right, this is plus minus here, okay? Plus minus. So you move A to the right. Then you can also write in the following form. Okay. So if the final term can be expressed in this form, then I is going to be called, I is actually, then you can say that it is increased by R% if it's positive, and if it's a negative, then we say decreased by R%. Okay, so those are the relation or the formulas, and let's look at the next problem. Okay, the side of a square is increased by 50%. By what percent? This is the problem number 80, the last one. By what percent is the area increased? Okay. Now, how do you solve this problem? You can do the following. Here's A, right? This is area is A squared. Okay, so you enlarge, the side is increased to A prime. It's increased by 50%. 50% means you look at the above formula. It's gonna be 1 plus 50 over 100 times 8. So actually it's 1.58. Okay. So 1.58, right? Then you square it. So A prime is A prime squared. It's 1.58 squared. Let's square it. If I square it, 1.5 squared is going to be 2.25. Okay, so it is going to be 2.25. A squared is 8, original area. So the new area is 2.25 times the original area. But how can I figure out the percentage? I can do two different ways. I can calculate that directly. I can also express in the following form. It's going to be 1.25 A. That's going to be 125 divided by 100 A. So if we can express it like that, I is going to be 125. So this is it. So area is increased by 125%. Okay, but you can also get 105% using this formula. Okay, so it's gonna be A divided by A divided by 100%, and this is, so I look at the rectangle is increased by 10%, and the width is decreased by 10%. So one side is increased, the other side is decreased. My question is, does the area change and by what percent? Okay. Okay. My question is, by what percent is the area change? Or you cannot determine. You know, there are many answers. The answer can be, okay, we don't know. It depends on the dimension of the rectangle. The rectangle is not given, right? All right. So you're going to change the rectangle, right? It's getting longer, and you see that, right? This is a change. Okay. And the new length is increased by 10%. It's 1.1 L. The width is decreased by 10%. So it's W prime is going to be 1 minus 0.1. So it's 0.9 W. Can you see that? Because how do you get 0.9 W? Because W, yeah, it's going to be 1 minus decreased by 10%, 10 over 100 W. So that's the reason it's 0.9 W. Okay. The new length is 1 plus increase. So it's 1.1 L. Okay. But so the area, the area of the new rectangle is going to be L prime and W prime, right? You multiply this out. So it's going to be 0.9 times 1.1 and LW. LW is nothing but just the original area. So it's going to be, what is the number here? Okay, this is 0.99, right? And A, clearly it's smaller than the original area. Okay, before you do the computation, you probably don't know. Okay, so if we express it in this form, it's going to be 0.99, right? So sorry, I should have said that 1 over 100. Okay, so it's decreased by 1%. The area is decreased. Okay. So when you change the size of the rectangle, one side increases, one decrease. You always decrease the area. I'm surprised. Okay, but before you do the computation, you don't know that, right? Great, you did a good job, very fast, and get the answer, right answer. Okay, so this is the end of the lecture, but my request is those students who are doing the homework before the class start, okay? Before next Thursday, those who are taking my class on Friday, send me the list of the problems you have a trouble to figure it out. You need more discussion, okay? So I cannot cover all the problems you couldn't do or miss, but if you give me the list of the problems, don't give me too many, okay? 5 maximum, okay? 5 to 6. That's very normal. If you couldn't do 5 problems, it's very normal. And then I collect them and look at, and I will try to discuss in the class. Okay, then this is the way we can improve. Okay, yeah.